Okay, so this is acid-base titrations, the worksheet. This is for the college prep class. If you're in the honors class, please, your worksheet's a little bit different. Can you please go to that video instead? So first of all, in your book, it might say something about H plus equivalences and OH minus equivalences, and I just want you to get rid of those. Just that was a leftover. I was making the worksheet from my honors worksheet, and that got left over. So just get rid of that. So then, this is on table T. You don't need to memorize it. It's on reference table T, where M stands for molarity and V stands for volume. Now, A's and B's, I didn't write in here, but A is acid, and B is base. On table T, it says concentration of H+. Well, that should mean acid to you. Acids have H+. And bases is the concentration of OH-. Now, that's another good question. So if you look in all these different calculations, they don't tell you who the acid is and who the base is. So you need to figure that out. Who is an acid? Well, you need reference table K to figure out who the acids are. Who are the bases? They're on table L. All right. Now, you should definitely have a calculator close by. And here we go. A 25 milliliter sample of HCl was titrated to the endpoint with 15 milliliters of 2 molar NaOH. What is the molarity of HCl? First thing I need to do is figure out who's the acid, who's the base. So let's go to table K and figure out who's the acid. So on table K, you'll see the first one listed is HCl, hydrochloric acid. So acid is going to be HCl. So anything having to do with HCl, I'm going to use this pink. So 25 milliliters of HCl. What was the molarity of HCl? So it looks like that's going to be our variable. So Ma, you can call it X if you want. And I'm going to put 25.0 right here. Which means the rest of that stuff is going to be base. 15 milliliters, 2 molar NaOH, which is table L. It's called sodium hydroxide. 2 molar times 15 milliliters. Okay? So now it's just a matter of doing some algebra. So we're going to multiply those two things together and get the same thing. Let's multiply 15 times 2, and you're going to get 30 equals that times 25. So let's divide both sides by 25. I do apologize, this pen is not great, and that should be 25, not 2.5. So 30 divided by 25 is 1.2. So our answer is 1.2 molar. That is the molarity of the HCl. So acid, NaOH. Okay? Let's go to the next one. Who is acid, who is base? Let's do that first. So H2SO4 and BaOH taken twice. So H2SO4, that is on table K. It's called sulfuric acid. So H2SO4, which means that the base is the barium hydroxide. So messy, I apologize. Now that is not on table L, but since I know the acid is the sulfuric acid, I don't need to go any further. So let's talk about what kind of numbers we're going with for the acid. 10 milliliters. What is the molarity of that again? So once again, we're looking for Ma. Call it X if you want. 10. And I'm not going to worry about that decimal place. I'm not going to worry about sig figs right now. And I'll use blue for base. Now that says 13.5. Sorry, it's hard to read. 13.5. And then the 1 molar. Now, you'll notice that the formula says molarity comes first and then the volume. But you'll notice now I just wrote volume first. It's because of the commutative property of multiplication. It doesn't matter which way you write them. So 13.5 times 1 is 13.5. And 10 times X. So let's just divide both sides by 10. And you get 1.35 molar. That is the molarity of your acid. Okay? Let's scooch this down a little bit. Excuse me. First thing we should do in the next one is to identify who's acid, who's base. So aluminum hydroxide, that is not on either table K or L, so I'm just going to keep moving. H3PO4, that's called phosphoric acid. So H3PO4 is our acid. So that must mean this thing is the base, which it should make sense because bases contain hydroxide. So let's just line it up since I've got my pink here. 2.5 times 20 equals, sorry about the coughing, and then 1.5 times, I don't know the volume of the base. Put it as X if you'd like. Okay, let's go ahead and multiply these two things together. 20 times 2.5 is 50 equals that. Divide both sides by 1.5. This is algebra, folks, so hopefully this is familiar to you. So 50 divided by 1.5 is going to give me 33.3 repeating. I can't have repeating volume. I can't have repeating milliliters, so let's just cut it off. Let's just say 33.3 milliliters. And that would be of the base. All right. How much of 0.5 molar HNO3 is necessary to titrate 25 milliliters of 0.05 LaOH solution to the endpoint? First thing you have to do is identify who's acid, who's base. So I'm taking a look at table K. I see HNO3 is something called nitrous acid. HNO3. So how much? That means volume. So I'm looking for the volume of the acid. So I've got 0.5. I'll use parentheses because it makes it a little bit easier to see. Don't know that. Which means that the 0.05 lithium hydroxide and 25 has to do with base. 0.05, 25. All right, now let's do some math. Looks like you would multiply those two things together, 0.05 times 25, which is 1.2, that's a 1.25. Divide both sides by 0.5 to get that by itself, and you get 2.5. What are the units? Well, what are we solving for? I'm solving for how much, which is a volume, 2.5 milliliters. How did I know it was milliliters and not liters? Well, because it says milliliters on this side. We would use milliliters on that side. Finally, the last one. I'm going to make that easier to see. What is the molarity of an NaOH solution if 15 milliliters is exactly neutralized by 7.5 milliliters of a 0.02 molar, that thing. Okay, so what is NaOH? NaOH is not on table K, but it's on table L. It's a base. It's called sodium hydroxide. So what is the molarity of that? So that's molarity of the base. Times 15. Now you notice I put it on the left side. Can I do that? Yes, I can do that because commutative property of multiplication. As long as you put the acid stuff together and the base stuff together, you're good. So this says 0.02 and this is 7.5. Okay, now let's do the math. So we need to divide both sides by 15. That would give MB by itself. So 0.02 times 7.5. I get an answer, which is 0.15. Divide it by 15, and I get 0.01. In the units, what is the molarity? Capital M for molarity. So I think the takeaway from this is you really just need to identify who's acid, who's base, and you can use the reference tables to help you. And then when you kind of pair those things up, it's just simple algebra and you should be good to go. So hopefully this helped, and if not, please reach out. Thanks. Take care.